Phase Change Engineering Internship Day 5, Designing Portable Incubators. If you're watching the video instructions, they cover the entire lesson, so you will need to pause the video when necessary. Activity 1, Connecting to Futura Workspace. You'll read and pin today's message, Designing Incubators. Then you'll add your daily message notes by creating a new header with today's date and message topic. Students open Futura Workspace and read the daily message from the project director. Remember that the new message, titled Day 5, Designing Incubators, should be at the top of the inbox and that you should pin the message. Add notes at the top of your existing daily message notes with the new heading, Day 5, Designing Incubators. All the notes you take for this message should fall under this heading. Ensure that you are clear for your tasks for the day, recording several designs on baby warmer data sheets, submitting baby warmer designs for feedback, after hours, reading and annotating the Meet an Engineer Who Works with Genetics Equipment article. Teacher, introducing the design cycle. Today you will start designing your portable incubators. Futura created a video to illustrate the design cycle and how it relates to your work. Students, play the video. What did you learn about the steps of the design cycle from the video? Let's review the steps of the design cycle as follows. In the plan step, engineers think about the project criteria and make a plan for a design that addresses those criteria. While planning their designs, engineers might also consider additional constraints that arise from their scientific knowledge. For example, during the research phase, you might have noted that some PCMs don't get hot enough while others get too hot. Additionally, some PCMs take too long to recharge. All of these findings should influence how you plan your initial incubator designs. In the build step, engineers create a design. In many cases, engineers build or use models rather than the actual product, so they can make quick changes to their designs. Some models are small, physical replicas, and others can be computer-based. For this internship, you are using the Baby Warmer Design tool to build and test models of your designs. In the test step, engineers run the test to get the results. These outcomes help engineers figure out how well their designs work. In the analyze step, engineers carefully examine test results. They consider how well the test results address the project criteria and identify areas that need improvement, sometimes by comparing versions. Based on the analysis, engineers return to the planning stage. They think about what they can change in their design to better address the criteria in their next iterative test. In this way, engineers progress through the design cycle multiple times. You may remember hearing or reading the term iterative testing or iteration in the video. Iterative testing, repeating a process in a way that considers the results of a previous design. At Futura, engineers conduct iterative testing with the goal of improving the final design. The design process involves a series of tests in which the results of the most recent test influence the changes made on the next test. This type of testing is called iterative testing. Each test influences the next test. Tests are not random. Iterative testing is testing with a purpose, and each result gives engineers the information they need to rebuild their designs by carefully changing only one thing, or one type of thing, each time. You'll use these baby warmer data sheets as you go through the design cycle. Let's watch a demonstration of how to fill out the sheets. These data tables reflect the steps of the design cycle. These sheets are extremely important for tracking versions of the design because they are a record of the strategies used in different designs. Students, play the video. What questions do you have about the baby warmer data sheets? Remember, you will have to think about all of your test results to figure out an optimal portable baby incubator design. The Analyze section is where you'll think about what worked and what did not work in each version. This is why the design cycle is a circle, because each Analyze section leads to the Plan section for the next version of the iterative test. Teacher, testing incubator designs. You'll use Baby Warmer to build and test your designs. What questions do you have about how Baby Warmer works? You can rewatch the Baby Warmer Design Tool tutorial video by returning to the digital resources. Remember, Futura Baby Warmer is a design tool that lets you create models of your solutions. Models of all kinds, both physical and digital, are important for testing solutions. You should test several different versions of your design. Record all results, even weak results, because you can learn from what doesn't work. Evaluating each design. You can think about these questions as you evaluate each design. When did the baby's temperature get too low? When did it get too high? What can you change to reduce the time outside the healthy temperature range? What can you change to make the baby's average temperature closer to 37 Celsius? What can you change to reduce the cost? As you analyze tests, you'll need to think about causes and effects related to phase change and energy transfer in order to predict which designs or changes to designs may work best. Decide which criterion is your top priority and plan some strategies to address that criterion in your designs. For example, some of you may want to prioritize making the baby's average temperature as close to 37 Celsius as possible, while others may want to prioritize having the fewest minutes outside of the healthy temperature range. Build and test several versions of your portable baby incubator. Analyze each version before you plan the next and record your data. Remember to carefully record all steps of the design cycle on your baby warmer data sheets. Don't rush through your analyze or plan steps. Think critically about each version's results, making thoughtful changes that can improve the results for the next version. Teacher, analyzing designs. What successful strategies did you use while testing? What problems did you have, if any? Were any of your designs strong for one criterion but not the others? How do you know? At this point, you might think you have a great design already, but you should check in with the project director, Anton. Engineers often look for patterns in the data to help them understand the effects of changes they make to the systems they are designing. For example, what pattern did you notice about the effect of adding insulation? We might say the baby cools more slowly and has less time outside the healthy range. What other patterns in the data did you notice? An example, using more than one kind of PCM decreases time outside the healthy range. Let's analyze some example data together. We'll look at the values and figure out which incubator design does a better job of addressing each of the criteria. You will analyze your data using this method. In order to identify your strongest design so far, you'll need to compare all of the results from all of your completed iterative tests. Example baby warmer data. Which version does a better job of keeping the baby's average temperature as close to 37 Celsius as possible? Version 4 has the baby's average temperature closer to 37 Celsius. Keeping the baby's average temperature as close to 37 Celsius as possible is important because if the baby's average temperature is too high or too low, the baby can't grow and develop properly. Large temperature changes can be dangerous for babies, so we want to make sure the baby doesn't spend too much time outside the healthy range. Which version does a better job of minimizing time outside the healthy temperature range? Version 4. Minimizing time outside the healthy temperature range is important because large temperature changes can be dangerous for babies, so we want to make sure the baby doesn't spend too much time outside the healthy range. The less a particular design costs, the more incubators the GHO can get to babies in need. Which version has the lower incubator cost? Version 3. Keeping costs low is important because the less a particular design costs, the more incubators the GHO can get to babies in need. You'll mark the best result for each criterion to help you choose the best overall design. Let's discuss an example together and think about how to decide. Notice the green circles around the best values for each criterion and compare the two versions. Neither of these versions strongly addresses all of the criteria. Which version would you submit and why? Version 4 is stronger because it has the best results for two of the criteria, keeping the baby's average temperature as close to 37 degrees Celsius as possible and minimizing the time outside of the healthy temperature range. You'll choose your strongest design to submit for feedback from the project director. You may notice that there is no perfect plan. In order to more strongly address one criterion, you'll have to make sacrifices in addressing the others. These are trade-offs. There are trade-offs between designs. For example, in version 4, the baby's average temperature and time outside the healthy range look stronger, but the cost is better for version 3. If we want to keep a strong average temperature and time outside of the healthy range, we may want to be okay with having a higher total cost. These choices will depend on what you have identified as a priority. Discuss your results and highlight the best result for each criterion. Choose your strongest overall design and mark it with a star. The star will help you remember which version you submitted, so you can use this version as a starting point for your next iteration and apply the feedback you receive from Anton. You'll submit just one design per team. In your future inbox, you'll choose the Baby Warmer Design form. Complete the Baby Warmer Design form, leave out commas and dollar signs, and double-check your data before submitting. If you're working with a partner, choose one device to use for your submission. If the second partner submits a design after the first, the last submitted form is the only one viewable in the intern's coordinator's Futura workspace. This can be beneficial if you change your minds or you make a mistake when submitting the form the first time. Activity 2, After Hours Work. For this task, you'll read an article called Meet an Engineer Who Works with Genetics Equipment, because Anton wants you to learn about possible careers in chemical engineering. Students, complete the task after hours. End of lesson.